vulnerability researcher, David Litchfield, disclosed an unpatched Oracle vulnerability. This vulnerability affects all versions of Oracle, at least since Oracle 9i. And during his presentation, David made available working proof of concept exploit code. Oracle has not announced a patch to fix this vulnerability yet. However, we have received confirmation that they do intend to patch it, as well as fix it in mainline code. So we will see a fix implemented in a future CPU, as well as future database releases. However, our team has done significant research into the July 2012 CPU that Oracle released a couple of weeks ago, and we found in there that they had made a fix for Oracle 10G Release 2 only. We've gone to Oracle and asked them to verify that this fix is in place, and they have refused to acknowledge our request for information, which is very typical of Oracle's kind of security disclosure policy. They do their best to keep these things very quiet, which is why we're here talking about it today. I'll give you a little bit of details about the vulnerability that was announced. This is a privilege escalation attack that works using SQL injection. And what it allows an attacker to do is run any SQL code as sysdba, or the root user of the Oracle database. In this case, the weakness is in Oracle's indexing system, and we've seen a lot of vulnerabilities in Oracle's indexing system over the years. In fact, David's presentation at Black Hat was all about the history of weaknesses in Oracle's indexing system. In this case, the component that's affected is called Oracle Text. If you've been using Oracle for a long time, you may know Oracle Text as Oracle Intermedia, and if you've been using it for a really long time, you may know that that is context. But it's the Oracle Text component that's affected here. Got the word CTXsys there. The CTXsys user and schema is what needs to be installed in Oracle for this vulnerability to work. This is a remotely exploitable vulnerability, but it does require authentication, and it requires some privileges beyond the default public privileges. Specifically, create procedure and create table are the privileges that you should have to be able to exploit this vulnerability. Now, before I move on, I should explain that you actually don't need either create procedure or create table to run this exploit. You simply need a table in your own schema that you have rights to modify. So somebody may create a table for you if you don't have create table rights. And once that table is created in your schema, you automatically have the rights to edit and add columns and add indexes, which is what's really needed to execute this attack. On the create procedure side, create procedure makes this far, far easier and more reasonable to execute, but there are techniques that allow you to run code similar to using create procedure that don't require that particular privilege, but those are fairly advanced techniques that your typical hacker is not going to have in their back pocket. So create procedure and create table are the privileges we're really concerned about, but if you've got a highly critical system, you may want to reach out to us and have a deeper discussion about the other ways that this could be exploited. This vulnerability allows for full compromise of confidentiality, integrity, and availability of data in the database. So this is potentially a bad one in the end. And again, it impacts all the modern versions of Oracle. So if you're running anything from Oracle 9i up through 11G Release 2, you're susceptible here. Let's walk through the attack step by step so you can see what actually happens here, the level of privileges that are required, and the results. So we'll get started by logging into the database as a DBA user, just to gather some information about the database, and then to create our attacker user. So we'll use Oracle SQL Plus tool, we'll log into sysdba, and the first thing we'll do is just grab the banner information, just to show you that we're running 11G Release 2. So you can see here, this is Oracle 11G Enterprise Edition 11.2. That's 11G Release 2. This one's running on Linux, and you can see that a little further down on the screen. Next step, let's create our attacker user. So we're going to create a new user. The username is going to be Hacker Harry. Identified by hacker gives us a password called hacker. And then we're going to assign the user a default table space called users and give that user a quota on that table space. any table space will work. User just needs to have some quota in the table space, which you'll basically always have if you've got any kind of create procedure, create table, or other rights to create your own object. So once we've created the user, we've got to grant that user some privileges. We're going to grant create session, which allows the user to log into the database. We're going to grant create table, and we're going to grant create procedure. So those three privileges will go to the user Hacker Harry. We'll run that, and now we're all set up. We've got our attacker user. The attacker user's got their kind of simple base privileges. So let's turn around and use SQL+. This time, let's log in as Hacker Harry. So we'll type that Hacker Harry username, the password hacker, and we'll get connected to Oracle. If I check my privileges, you'll see that I've got the privileges I assigned: create session, create table, create procedure. Oracle also generously gives me create user and create role. They have no impact here. So let me try to just make myself the DBA. I'll run the command set role DBA, and I get an error from Oracle: role DBA not granted or does not exist. This is good Oracle security here. If you don't have privileges on an object or on a role, Oracle will sort of deny that it even exists. So either we haven't been granted the DBA role or the DBA role doesn't exist. One way or the other, we're not getting DBA rights here. So let's set ourselves up. The first thing we're going to do is we're going to use that create procedure privilege to create a function. We're going to create a function called X. And as you can see here, it returns a value varchar. That's not very important to us. The next line, auth ID current user, is very important. That tells us that this is an invoker rights function, meaning that the login or user that runs this function is going to be the set of privileges that are used to execute this function. So what we're really going to do here is trick a more powerful user, in this case sys, into running this function for us, which will run with sys's privileges, and then we can execute any SQL we want. In this case, the SQL we've chosen to execute is right here, grant DBA to Hacker Harry. So I want to make myself the DBA. So we get our procedure set up, Oracle compiles it, gets created. Now let's actually do our SQL injection. So I'm going to take advantage of my create table privilege, and I'm going to create a new table in my schema called TBL. 2 columns in it. The first column is, you can see it's called ID. It's a number, and it's not allowed to be null. The second column has a pretty funky name there. And you can see that in that name there's a little bit of text. There's a couple of pipes. There's a reference to the function that I just created, hackerharry.x, a couple of more pipes, some single quotes, and some more text, and it's defined as a blob. So the name of that column is a very funky column name, and that's where we're injecting SQL, is into the name of the column. So I'll create the table. Oracle will give me a table with just about any column name, so it's happy to create that table for me. If I've created a table and I own it, I have the ability to create an index on that table. So I'll now go ahead and create an index called the next table on my table TBL on that column where I've injected SQL. The important part here is that the index type is set to ctxsys.context. That's why we're calling it the ctxsys.context SQL injection, because the special index type we're using here to make this work is a ctxsys.context index type. Again, Oracle's happy to create the index for me. The next step is to run this function dbms stats.gather table stats. So this dbms stats package is got execute rights granted to public by default, so everybody in the database can run this. However, there's another caveat to this exploit. I actually don't need the rights necessarily to execute dbms stat. That's very commonly run on a recurring and regular basis by a DBA user or a background process just to keep the database optimized. So in this case, I'm taking advantage of the public privileges on this package because they're going to be there better than 99% of the time. But even on systems where they aren't there, there's still potentially some risk. So we'll run gather table statistics. That'll do its thing. And then finally, the last step in our attack here is to drop the table. And it's actually when we drop the table that our SQL injection attack comes together. The SQL code that we've stuffed in there, that call to our function called X, gets executed, and we get our privileges. So the table gets dropped. And And now we're ready to assume DBA role. And here we'll go back to set role DBA, just like we did earlier. This time Oracle's happy to give me DBA rights because, well, we injected SQL. That SQL ran as sys. We were able to escalate our privileges to DBA, and now we have full rights in the database. So finally, if I do something like access really sensitive data, like names and passwords, to log into Oracle, no problem. Oracle will give me the sys password. It'll give me the system password. It'll give me every other password that's sitting in the system. And you'll notice these are password hashes. So we know Oracle's password hashing mechanism, Oracle's salting mechanism, and it's fairly trivial to go back and break these passwords using freely available password cracking tools. But this is just an example. Any data in the database, your intellectual property, your HR information, your customer information, the secret recipe for your new beverage, if it's sitting in a database, it's accessible by a DBA user, and that DBA user may have been created as a result of this exploit. So it's pretty simple. There's a few steps here, but as you can see, this is really a simple cut and paste of the exploit code that was made available during that Black Hat. So there are a few things you can do to work around this issue and mitigate the risk. The best and probably easiest thing to do is to remove Oracle text. So what Oracle text is for is to allow you to manipulate, search, and work with text fields in the database. It allows you to search text and return search results with the specific keywords highlighted. It lets you look for articles that are about a particular topic. It's got all sorts of powerful features for searching, finding, and manipulating text. If you're not using powerful features to search and find and manipulate text, and the chances are you're not, you can remove Oracle text. Now, Oracle text is installed by default, but Oracle does provide a script to remove that from the system. So pretty simple option. If you're not using Oracle text, rip it out, limit the surface area of the database for attackers to take advantage of, and just take the vulnerable code right out of your system. If you are using Oracle text, let's move on to the next option here. Revoke create procedure and create table where possible. So don't grant these privileges to any users unless they need these privileges. In a production system, that should only be your database administrators. In a test or a development system, it's very likely that developers are going to need these privileges, but you're going to want to control them very, very carefully and make sure that you actually watch the use of these privileges where you can't revoke them. You could also look at revoking public execute rights on DBMS stats. Now, if you do that, you're going to need to re-grant rights on DBMS stats to the users that need to run that functionality. That's good practice, and I recommend that you do it, although it will take some testing in the database to figure out what, if anything, breaks when you revoke those public privileges. If you're not able to remove Oracle text, and you've got users that still have create procedure or create table, then the next thing you want to do is use database activity monitoring to identify and stop any attempted exploits. So there's a bunch of database activity monitoring tools out there. I believe the majority of you on this call are application security and customers. Of course, we've got DB Protect for database activity monitoring, and I'll show you in just a minute how you can use DB Protect to detect this exploit and stop it. Finally, if you're running 11G Release 2, apply the July CPU. Oracle's not saying that this issue's fixed, but I can confirm that we've found this change that Oracle made in their source code in that CPU and saw it fixing the improper input validation that they've done previously. So July 12 CPU will fix this issue on 11G Release 2 only. It will not fix this issue on 11G Release 1 or on 10GR2. And as you know, Oracle doesn't patch 10GR1 or 9i or anything older than that. So this probably leaves your organization vulnerable. However, this is not the same level of red alert that we had earlier this year in May with the TNS poisoning vulnerability, which, by the way, is still unpatched and is not going to be patched for a long time. And if you don't know about TNS poisoning, just go up and look at our webinar archives, and you'll find a webinar just like this one that goes into detail about TNS poisoning. Even though this isn't as scary as TNS poisoning, which allowed users without any login to Oracle to assume full DBA rights, it still is a high-risk vulnerability, and it's something that you want to pay attention to on any Oracle database connected to your network, not just the critical ones with your sensitive data, as if somebody can take advantage of another Oracle database that's out there, maybe not so sensitive, it's very likely that they'll be able to leverage links, network trust relationships to get to other sensitive systems in your environment. Application security is here to help, and we can help you right now. We can help you to identify vulnerable systems, identify users on those vulnerable systems that can actually run this exploit, and then help you to identify and stop live attempts at running the exploit. So what we're offering is a custom policy to identify vulnerable systems and users with exploit potential. We're offering attack detection rules to alert on any attempted exploits. And of course, our active response system is there to stop those attempted exploits. And as always, we're here to offer advice and guidance and security intelligence to our customer base and to those of you that reach out to us. So I'm going to show you how to use our products to identify this. I'm going to use a mix of App Detective Pro and DB Protect because I know that you folks on the call use a mix of App Detective Pro and DB Protect. But I'm going to focus a little more on App Detective Pro, primarily because if you're not one of my customers right now, you are welcome to come to our website and download a free copy of App Detective Pro that you can then use to scan your databases and identify this vulnerability. So we've made our App Detective Pro software available on a limited basis for free to those folks that are not our customers to help you protect yourself from this vulnerability. So let's walk through a couple of screenshots here. Here's a screenshot of App Detective Pro. We found a few databases on the network. You can see that we've got Oracle 11G databases here. If the version is 11G, we know we're vulnerable. So the next thing we're going to do is go ahead and scan one of those databases with the new policy that we've created. So we created a policy called ctxsys.context SQL injection policy. I'll show you where to download that in just a moment. You're going to go ahead and audit the database using that new policy. Once the audit is run, you can take a look at the audit results. So here I've just opened up our check status view, and you can see the few checks that we've included in that policy and the status of those checks. So here I've got, as you can see, create procedure that's been granted, create table that's been granted, Oracle text is installed on this system. There are public privileges on DBMS stats, and I've got users that either have unlimited table space or quota on some table space. So all the conditions that are necessary to have a vulnerable system and to very likely have exploitable users that can run the exploit are here. So once we see this, we want to dig in a little further and figure out exactly which users can run the exploit. To do that, we're going to take a look at the detailed check results. So here's a couple of snippets out of App Detective report and screen. And I've just highlighted one particular user that can run this exploit. So in the top section, we're looking at create procedure granted to user or role. And here we have a user named developer that's been granted create procedure. In the second section, we're looking at create table granted to user or role. And once again, we see that user named developer that's been granted create table. Finally, in the bottom section, we've got users with quota on any table space. So that's users that can create objects, once again granted to developer. So user developer has all of the privileges required to run this exploit. I just simply have to look at the results coming out of App Detective Pro to identify them. Now I do have to correlate some results here, as you can see, manually by hand. That's only going to be for a little bit. Application security and our team Shatter are working on a check that we'll be rolling out in our next knowledge base release. As you know, we do that every month, and we've got one coming up soon. That will just be a built-in ctxsys.context SQL injection check that'll check all these conditions for you. But if you want to know right now if you're vulnerable and right now which users can exploit that vulnerability, this is the way you do it, and it's not going to take you much work. And in fact, if you're running DB Protect, it's even easier. So if you've got rights management installed, simply go to the System Privileges for Users report, filter that report. So at the top of the screen, you can see I've set up a filter, and I've filtered on privilege name for both create procedure and create table. That's just going to display any users that have got these particular privileges. Now looking at the report data itself, here's a couple of snippets. And again, we can see that here's the user developer one more time, showing up with the privileges that we need. And if you look through this list, you'll actually see that a bunch of users have the privileges that you need. In fact, the built-in Oracle role resource just happens to have everything all put together to run this exploit. Create procedure, create table, and you can't see it on this screen, but resources also got unlimited table space so that they can create objects. So you'll be able to use reports like the system privileges report from rights management to very quickly pinpoint the users that have all the combination of privileges. And of course, the scan policy that I showed with AppDetective Pro can also be imported into your DB Protect vulnerability management system and run there. Finally, we've got our real-time monitoring. So we'll give you the ability to alert on any attempt to exploit this vulnerability. So we've written a new rule. We've made it available as a filter to make it available immediately. The filter is called Context Index SQL Injection. And here you can see an example of that rule firing in DB Protect Activity Monitoring, which is actually catching a user creating an index type of ctxsys.context and injecting a function call into the column name that's being indexed. So we've written a very powerful filter here that you'll be able to deploy to your systems immediately today that will identify, alert, and then optionally using active response, and that's up to you, block attempts to exploit this vulnerability. We've really got you covered here. So where do you get all this information? Come up to our customer support portal, type in your login, navigate through downloads to product downloads and zero-day references, and then you'll see in those zero-day references, the only thing you'll see there are the ctxsys.context policy for scanning and filter for monitoring. So this is available to our customers. Again, right now, this is already up. Go ahead and download it. If you are not an application security customer, again, we've made AppDetector Pro available for download for free. Just go up to our website and download it. If you are unable to do that, or just want further information on what queries you could run with a script to identify these vulnerable systems, please feel free to contact us, and we'll be happy to provide you with those scripts that you can run outside of our product to help you identify the vulnerability. But it'll sure be easier for you and a little bit easier for us if you just grab AppDetector Pro and go ahead and run with it. So the situation is one that we need to be concerned about, but we can protect ourselves today. I recommend that you don't wait to act. Go ahead and implement these workarounds. Patch your 11G Release 2 databases as quickly as you can with that July CPU. And if you have any questions at all, please contact us. You can see a number of ways to contact us. You can ask questions right now on the webinar, and I'd be happy to help. Up on our teamshatter.com vulnerability research website, there's a detailed blog post written by our Director of Security Research, Alex Rocketer. That'll walk you through a lot of information about this specific vulnerability, about the privileges required, and it'll give you some really good, solid information. No login required, of course, on teamshatter.com. Just go up there and you'll be able to grab that information for yourself. But before I move to questions, I want to let you know that I just showed you some live proof of concept exploit code. This exploit code has been shown before by the security researcher at Black Hat last week. However, it's not widely available on the internet today. So we are not going to be making this presentation available for public download, at least not right away, simply because we don't want to be handing out exploit code to anybody who wants it. We will, however, make the presentation available by request. So if you would like to get this presentation to show your colleagues, please reach out to us. We'll chat with you and we'll get you a copy of the presentation. So just want to make you aware of that. That's all I've got. And I'm available here to answer any questions that you folks have. Just go ahead and type those questions into your control panel. On the right side of the screen, you'll see a little question section. So I've got a question coming in from Sylvain asking what the overhead of the product is. I assume, Sylvain, you're asking me how much database resource it's going to take you to run this scan or to monitor for this exploit. You're really not going to see any impact on your database performance. To run the scan, we're going to do a few very simple select statements. They're designed only to return rows if the system is vulnerable, so we'll see just maybe a few dozen rows coming back from your database. No joins or anything like that, so you'll see really no impact running the scan. In order to monitor for this vulnerability being exploited, you would install our database activity monitoring, which typically will have an impact on your database throughput or response time of about 2%. But that's very policy dependent, and if you're just looking for this exploit, you're not going to see any impact on database round trip time. Got a question from Mark asking if we need to update the sensors. Mark, you do not need to upgrade your sensors. The filter we've released will work on all supported versions of DB Protect sensors, and honestly, it'll probably work on all unsupported versions, the older versions as well. So you'll be good to go with your current sensor deployment. Got a question for a copy of the presentation. Jerry will contact you afterwards and hook you up. Robert asks if to run this scan, we need a regular database audit account, or do we need an OS account? Robert, we only need to access the database. None of the information that's required needs to be pulled out of the operating system. So minimal privileged database login with our typical select rights on the catalog will get you what you need. A number of folks asking for presentation copies. We'll reach out to each one of you afterwards and get you that. Sven asks that Oracle text is often used for search engines, and it sure is. And so it's difficult to disable. It's definitely difficult on those systems where it's being used. So are there best practices for using Oracle text in a secure manner? There are. Oracle text, it comes with a bunch of public privileges. So one of the things that you can do is go ahead and revoke the public privileges that are granted on the CTX schema objects, and only grant those privileges to the users that are going to be executing Oracle text functions. You can also monitor the use of those functions. You probably don't want to monitor everything. There could be a lot of activity there, but at least the functions that we know are vulnerable, like the CTXsys.context index type, you can monitor for that kind of thing. So just kind of reading through the questions here. Sylvain came back. Another way to counter these are to disable some account. So that the account that needs to really be disabled it's really the CTXsys account. That's the Oracle text schema owner. But just disabling that login is not going to stop this from happening. You'd actually have to go in and rip out the CTXsys information, that really the Oracle text option, which you can do again with the script that Oracle provides. Javor mentions that in 11.2 one can create a table without a segment unless you don't put data inside. That's an interesting point, Javor. You may be able to, in fact you can in some table spaces create a table without a segment, but when you go to create the index, this will fail. So if you've got no quota assigned, this will definitely fail. I've tried that 17 different ways with no quota assigned. In Tarek, if the user is not able to create index type CTXsys.context index, then is there a vulnerability here? The vulnerable index type is the CTXsys.context index type. Now to create that, again, you need to own a table, and you need to have some rights on some functionality. There is a CTXsys piece of functionality, I think it's called CTXDDL, but don't quote me on that, that's required to create this type of index. If you revoke that privilege from public and grant it only to the users that need it, you're going to significantly reduce the potential for an attacker. From Helena, if CTX sys is locked and execute privilege is not granted to any account except for sys, we still have an issue. So locking the CTX sys account is not going to make any difference. Execute privilege on, I assume you mean DBMS stacks. If that's only granted to sys, then you're only going to have a problem if you've got a background process that periodically runs DBMS stacks, gather table statistics for you, which is not uncommon in databases for performance reasons. However, if you never run gather table stats and nobody can run gather table stats, then the setup for this attack can't be executed and you'll be okay. All right, it looks like the last remaining questions that are coming in are all requests for a copy of the presentation, and we will grab those requests and we will follow up with each of you and get you the material. Thank you folks for joining us today. Once again, this is Josh Shaul talking. You're welcome to reach out to me. I'm Josh at AppSecInc.com. Send me a note if you have any follow-up questions. Again, you've got our contact information on the screen. Make sure you can see that. If you just want to reach out to AppSecInc in general, and we'll route your requests to the right folks.